Okay, I'm going to start. What do you think? Yes,
Good.
people can join. That's fine. So I was chatting with Elmarie, right? And actually, I've been wanting to do this for a long time, and actually, like, I'm just terrible. So I thought what could be cool is to have like a focus on event-driven as a concept, right? Because I think we do a lot of event-driven stuff probably, and also I think event-driven is very interesting from an architectural perspective. So of course, like like Nick and the gang at VG and Yoni, etc., and Bavesh and like a whole bunch of people have been working with Kafka, and I know Paul Z and the Capitech gang are like playing with Flink and like a whole bunch of event kind of stuff, and it's mostly, I suppose, in the context of like data. And that totally makes sense. I mean, that totally does make sense. However, I think that it's interesting to try and understand event-driven from an architectural perspective. So what I was saying to Elmarie is like maybe it could be cool to have like maybe three. I don't think I can talk about event. Like I'm certainly not like an event-driven expert. That's for sure not. So I can like this is all my own opinion and interesting uh, like directions to it, or interesting ways to think maybe about event driven. And I thought like maybe there's like three different things. The first one's more like very theoretical, introduction to it, some hand waving, lots of hand waving. There will be lots of hand waving, some diagrams, architecture, maybe good, bad, like pros, cons, and then like discussion around different stuff because it's not obvious. And then potentially into like subsequent tech sessions or whatever, we could talk like in more detail, like practically, like let's look at actual technology stuff. And I thought it's very interesting because when I think we see a very natural fit in the front end world. So things like React and Redux and Angular, and like these are obviously event driven types of frameworks, but they're powered by some fundamental constructs underneath, stuff like observables, and promises and interesting things like that. So I think that's interesting to go and play with. And then I think also there's event driven when we think more around, and I say inspired by the back end, but that's much more like what around Kafka, Flink, impact on databases, etc. So I thought like maybe it could be cool as from a series perspective to say like let's do some theory today, and it's awesome. Because we can talk about event driven without all of the constraints of the physical world, which I think is brilliant. And then like number 2 and 3, we can say, well, okay, so how has that been how is that practically usable with like more front end type stuff, and then more with like back end type stuff, if that makes sense. So that's a kind of series thing. So I actually made my presentation a PDF. So I think you can see my mouse though, right? So I might use my mouse a bit. So this is episode 1. This is that first one. So this is just the hand waving and lots of rabbit holes. But I think it's interesting because we can think about event driven from a more theoretical perspective. So there's like definitely the theory, and then there's practice, absolutely. And practice is like, yes, Kafka, Flink, observables, Redux, React, all those things. And it's like and although you may love and cherish those things, those practical things, it's quite interesting to draw them back to maybe some more of the like theoretical stuff and kind of understand like, okay, so why do they do this? And like, how is this, like maybe this is a trade-off, right? This is to make it more practical, that we see that, maybe the laws of physics constrain more the practical side of things. Whereas in the theoretical world, we can think about things very theoretically, which is super cool. So today we're just going to talk about theoretical stuff. And also, dudes, maybe we should use the put up your hand mechanism. I can actually see your hand. So, but you're welcome to like stop me. Absolutely. Please don't make me make this a lecture, even though it probably will be. Like, put up your hand and like ask a question, even a DOF question. That would be cool. Thank you. It will make me feel more comfortable. Okay, so why do we do event driven? You have to start your slide with a why, right? And maybe these are some of the reasons that we've heard. So like, yeah, stuff's more modular maybe. Well, things are simpler. It's like easier to test maybe. Things are deterministic. We can do time travel type of debugging, that kind of thing. There's less dependencies, you may have heard. It's more scalable. And if it's more scalable, it's probably because it's easier to distribute, right? So those might be some of the reasons why you might talk about event-driven. But what is it like actually, right? And these are just some more words that might appear more in the what category of things. So it's like, it could be like event loops, it could be event sourcing, actors. There could be a tendency to have more of a pull versus a push in your architecture. CQRS is a big word. Highly that's more of a why. That's not a what. Highly distributable futures. That's something you might have heard about, or observables. Extremely loosely coupled. That's certainly a why, not a what. Functional reactive programming. This is another cool word. Reactive extensions. These are all good things. Like these are all the whats that may be part of the category of event-driven, right? It still doesn't tell us very much, right? Unless you dive into any one of these things. So like when I tried to define like what is event-driven, it's like it's not very easy to define, but there is a bunch of different things in there that you may consider to be event-driven things. And all of these things like probably are from a categorical perspective, right? So like what is it really? So like when this is how I distill it. So I go like, actually it's quite simple. It's like model your design, so your software design or your architecture, in terms of events rather than in terms of commands. It's as simple as that. So where you would normally sit down and say, okay, how do I solve this problem? Well, this customer needs this thing done. You would normally sit down and you would choose maybe naturally to model it in terms of commands. Like this system will tell that system to do something, or it will ask that system to get some data for it, or whatever, right? And that's very like a command oriented thing. So even like in a RESTful API or something, when you make a request to put an object onto an API, guess what? That's a command. You're saying put. You're not giving him any other. You're not suggesting it. You're just saying like do this thing, right? That's a command. I'm instructing you to do it. As opposed to an event, which is like, hey, this thing happened, and we'll dive into this a little bit more. But I think like fundamentally, that's kind of what event-driven means: a system modeled in terms of events rather than in terms of commands. And it's not to say either that they necessarily negate each other either. They may do to work against each other, but I do think that they can live together in some sense. Okay, so what is the command? So I just talked about this. So we've got system A, and sorry, all my slides are drawn by hand. I haven't done any prep, so I've made them so that I can follow along myself also. But so here's what a command looks like, right? You've got a system A, and you can think of these as like whatever. It could be the browser is A and B is an API, or you've got a service calling another service. Doesn't really matter. It's like two software things, right? And so service A just tells service B to do something, right? So it's like, hey, like add this user, or hey, log in, or do this, fetch me this piece of info or something, right? That's a command, right? Like A knows about B. It's super simple. We know this, right? We know the standard form of the diagram, which is square, arrow, another square. It's like, yeah, this is going to be a go do something type of model. Super simple, and it totally works. And like I would think very close to 100% of most software incorporates this in its design. However, so there's a small downside here that A knows about B. Like that's a byproduct of this design, right? B doesn't necessarily need to know about A, but A certainly knows about B. So from a coupling perspective, you could say that B is coupled to A, or A has a dependency on B, or something like that, right? And we're comfortable with that, right? And that's probably okay. Like most of the time, that is probably fine. However, so let's like zoom into that picture a little bit more, because it's not really the full picture. This is like A tell B to do something, right? So let's just zoom in like another level of detail. So it is still A saying, hey, do something to B. B probably says, yeah, okay, I'll do that. Like it's going to verify it or validate the thing is correct or whatever. And he probably, if this is like a change state type of command that he's been asked to do, he may go and persist that state somewhere. So although in my diagram it looks like it's a database, you can imagine that this is anything. I mean, it doesn't have to be, it's certainly not a database. I'm just representing state using the database notation. Certainly could be a database, but it could also just be like in memory, he increments a counter. Like in my diagram, that's still state being changed, right? So B goes, okay, cool, I got a request to do something. It looks okay. So let me go and do that, which is to like manipulate the state of whatever, something in memory or out to a database, or even maybe a service to another call to another service or whatever. And then at some point, he may fetch that state and he may return it to. So I've kind of like, I mean, I'm highly simplified this thing, but if it was like, and this is like a pure update, right? I want to change something on B. B goes and makes the change. He may, at his discretion, also like choose to fetch the new updated state maybe and return it to A. Or it could be that A subsequently, you know, after that thing is persisted, goes and fetches, asks B for it. It doesn't really matter. I'm conflating two things here: a change of state and a fetching of state. That's totally fine. We'll dive into that a little bit. Interestingly, though, when A is receiving that new state from B, so the thing that changed from B, if you think about it, like our little in A's little brain, he also has his own little state thingy, which could just be memory or whatever, or his own database. He like may persist a little bit of B's state in his state. I mean, it's probably quite logical that he may, even if it's just for a millisecond or maybe longer, who knows? And like and concretely, like I wrote a piece of code in some language that like shows you like absolutely. So it's like if A was a person service and B was an address service, you may very well find a piece of code like this, that in the person service, he keeps a list of addresses, right? And when he is constructed, he's going to go and fetch the addresses for this person or whatever, right, into his own memory. And it's like, this is not an out of place piece of code, right? You construct the person service with a particular person. Guess what? As part of that, you're going to go and fetch some information from another system for that person, right? And you're going to hold it in memory for a millisecond or maybe longer, right? I mean, that totally makes sense, right? You guys are comfortable with that. So in my crappy notation, it's like I'm showing that is like, okay, A's got a little bit of B's state inside his state. And it's like, well, there it is there. You can actually see it. The list of addresses actually in the code here. Yeah. Okay, so none of us should be surprised by this, right? Okay, so it gets a little bit more complicated, and so there's nothing really wrong with this. And there's nothing wrong at all with this. A lot of stuff looks like this, but it can tend to get complicated, and it gets complicated when potentially there's more consumers of that service. So say, for example, we've got a person service, which we just saw, but maybe there's a company service as one, a delivery service. And we still have that address service, which is like, and it's a very contrived example, but I think it works quite well. So the address service has got his own state. So he just manages people's addresses, right? He verifies that they're correct, and then returns you back like info when you ask for them, right? Of course, the person service we just saw is going to have little bits of state over time within his context of those addresses. Probably the same is true of those companies. So if you think about, you've got people who've got addresses, companies also have addresses. And then I've got a delivery service. So if someone places an order, there's a delivery service that gets kicked in. Like that delivery may have an address associated with it, or that dispatched order or whatever. So it makes sense that you may want to factor things out like this. Like addresses has become like this common dependency between these three things. And that totally is fine when things are being generally fetched. So it gets complicated when three services wants to perform an update. And of course we know this, because say the person service, so that person updates his address, suddenly we've got leaky bits of addresses sitting in the memory of other services downstream. They're disconnected, right? So updating the state in the address service doesn't necessarily update it back in the company service or back in the delivery service, if that makes sense. And so we have this tendency to always be like fetching, must fetch latest, right? That might be one of the downsides, right? But I mean, we live within this context, right? So if we look at that as a problem, like where would we go? So like these are the only three ways I solve problems. Number one, definitely Kubernetes. Kubernetes will solve this. Number two, stateless. Like stateless sounds like a good pattern. Immutable also sounds like a good pattern. And there's probably a bunch of others. I just put down some random comical. So Kubernetes obviously is not the solution. Yeah. So approach number one, like let's see if we can do it by making it stateless. So can we solve this problem through stateless? Because it isn't stateless, right? The address server's got state. So I'm not saying that the service or the RESTful calls are stateless calls. I'm saying the service itself is stateful. Even though it has a database, maybe it's offloading its state. Still, when you think of it as a total unit, it's a stateful thing, right? Addresses are being stored somewhere. It's got state. So let's say if we wanted to make it fully stateless, the address service must no longer hold state. Like not at all, right? It must have a database, it must have memory. So let's see that. So like, is that possible actually? So if we consider that approach, it's like, well, now maybe the person, so then what is the purpose of the address service if it doesn't hold state? Well, maybe he still has some purpose, because one of the things he was doing earlier is he was validating stuff. He was saying, yeah, this is an address, so I'm okay with this change. So like that's interesting. Validation is interesting. And technically he could just reply and say, so maybe he just becomes the validation of addresses, right? Service, but he doesn't himself hold or own the addresses. So he has no state. There's a little arrow with an X, no state. And he just replies to services saying, yeah, that address you gave me is good. And then it's up to the service, the calling service, like the person service, to actually store and maintain those addresses himself. And he just offloads the validation to the address service. So like that's interesting. And I put a comment there. It's like there's a marginalized benefit to the person service because the validation is offloaded, but like he still has to do all the cruddy stuff. So it's like, well, now the person service has got to manage addresses, right? So that means it's not that great. We've like kind of moved the storage problem into, we've pushed it out into the service. So it's like, okay, it's like not a bad approach. There's a second approach is like, can we make addresses immutable, or can we make things immutable? So instead of changing state, can we maybe just make new state that layers on top of old state, right? And this and so it's interesting. So when I think about that approach, it's like, well, actually, this is not a bad idea either. So now we have, if you think about it, you've got the person service calling update of addresses there, and addresses now go, instead of it having a single set of addresses for people, it now like every change creates a whole new like version kind of idea of those addresses, meaning that other services like company and delivery, they may have different versions of stuff. And so when they try to update addresses, like the address service can go, you've got an old version, and he can start to like gate things and say, oh no, you can't, like the version you've got is version 2, I'm already at version 3, and you're trying to commit a change, like that's based on version 2, I can reject it because I've got version 3 here. So it can try to be like the gatekeeper of data. And maybe this, so it's like maybe better, or it's maybe an idea. So we can certainly start to look down, if we're the person service, we can look at our data that we have, and we can go, this is old or new or something. We can at least like see the version of it. And we've also got the fact that like maybe people won't fight so much. But I don't know, yeah, like that's certainly, it's like complicated, but it could be done, right? I don't know if it gets us to what we want. You've still got the problem of like, you know, person's got an old version and company's got a newer version. It's like that fundamentally is still an issue. At least they can now see that issue. It doesn't really solve it though, right? So like event-driven, like those two things combined with some other stuff are kind of what event-driven starts to get us to. So let's think about like, so if we think about the fundamental problem that I've just like talked through, maybe you don't think that's a fundamental problem. That's fine. I think it is. Basically, what we want is we've got the state thing on the A, we've got on the B side, and different addresses, and A's got people in it or something, right? But there's little bits of B state that we want inside A state. I mean, that's fun. Like if we didn't have the laws of physics here, and we could like quantify stuff, like that's what we want, right? We want. And so I use this little orange arrow with the word projected, is we want to be able to project a piece of B's state into A's state, you know, like all the time. And so when I say it's projected, when B when B state changes, the projected state reflects it completely. So it's not like it's a projection once in time. It's like a permanent projection, right, of that thing. Does that kind of make sense? So it could be, and then I say that it could be temporary or permanent. Who knows? So like we got to take time out of this problem. It could be that A doesn't care about, certain parts of B's state. It only cares about it for like a moment in time, or it could care about it for a long time. It doesn't really matter. Fundamentally, we need this this dynamic projection of data. So if we had no laws of physics and we could use quantum entanglement, like that would be a really good solution actually to what we want, because A would never need to ever fetch anything from B. He would always just have it. He just has to look at his own state and go, oh yeah, here's the person's address. And when that changed, it's like, yeah, it's changed. I got it. It's like, I don't need to go and fetch it, right? Does that kind of make sense? So that like fundamentally is what we want, right? Of course, we can't have this physics, and quantum entanglement is not yet available to us. But I think that's what we want. So, and of course, like if we scale that out to the 3 service problem that we had earlier, it's like it's the same thing. So it's like A has a projected bit of B, and you can see that they're like different pieces of B's state projected into different parts of A, C, and D's state. Does that kind of make sense? And they could be like multiple projections. So it could be like, hey, like C has got this bit of that state from B, but he's just got the same one that A's got up there. You know what I mean? So it's like that's what we want actually. But what we probably don't want is this. I don't know whether we probably don't want this. I don't know. But like that also doesn't make sense, because so this is saying now, okay, but we can do this, because what we can do is we can just say, hey, A's state is B's state, right? So like you could think of this in the old school days where everything sat in one database and everything just like talked to itself, right? Like if something needed to like look up address, it would just query it directly, even though it had no, like let's break down all the boundaries of stuff, right? So we probably don't want that. We don't want this like full on, like then make them all the same kind of thing. It's like it's quite little pieces of data projected, not entire sets of, because I think that takes you down the route of saying, well, let's just put database and then it's all projected, like there's no requirement to project, something like that. So probably not that. So I do think when you take event-driven ideas and you distill them all the way up to the furthest extreme, I do think event-driven takes us to this idea that data can be projected into the state of things outside of the thing that owns that state, if that kind of makes sense. But it does do it but obviously it does it with a bunch of caveats and nasty physical world things incorporated because of the laws of physics and quantum mechanics, unfortunately. Okay, so let's go through it, right? Let's see how that works. So remember this, I think we do it was 10 minutes ago. We've got A telling B to do something. We called that a command. So A, do something. So even if it was like A fetching something from B, it's still a command to fetch it, right? So it doesn't always have to be like a state change. It could also be a state fetch. That's still a command in my opinion. With events, the way you may model that diagram is, and this is my notation, but this is how I would model it, is it's like, okay, we still have A, and we still have B, and we still have C, which is the same as A, I think. It's like he's the company service, and this was the person service, and that was the address service, is like A just says, hey, something happened. That's all. And then B goes, oh, that's interesting. Like the thing that happened was like, it's interesting to me. And of course, other services can go, yeah, I don't care actually about that thing that happened. So that's how you would model that diagram with events, is like nobody talks to anyone. It's just you've got services saying, hey, stuff happened. And other service going, ooh, stuff, like that's interesting, and stuff happened. Other stuff happened. And other services going, yeah, like I couldn't care that happened, but these other things that happened, I do care about those, and subsequently other stuff happened for me, right? So it's like imagine events like that. So I mean, it's not very useful because that's quite tricky. So like conceptually, you could think of it like those events that occurred, like the stuff happened or something happened, as like a series of events in like a pipe. Yeah, imagine it like a pipe, no problem. So if all of these services A, B, and C are putting the something happened event into that pipe, and they're registering for, and they're listening for events in that same pipe that they feel are interesting, you've kind of got it, right? And so A says, hey, something happened, and it just kind of emits it into a stream. So don't think Kafka, don't think Kafka yet, or anything like that. Just think conceptually around this thing, that you've got this conceptual pipe of events. So events have got some interesting properties, like they kind of keep their place in time, that kind of stuff. So if something happened after something else happened, it would tend to be after in the pipe. So the pipe has maybe got some concept of ordering in it, that events happen in some order, and that you have the ability to put events into it, and you can only really put them on the end. You can't really put events in the middle of other events, but you also have the ability to process events, and you just like, you kind of can just out of the pipe way the one. So you eat events, you go, yeah, I don't care about this, don't care. Oh, I care about one. There we go. I'm going to handle that. And maybe the way you handle it is however, and you can choose if something interesting happens because of your handling of that, then you emit a new event saying, oh yeah, something else interesting happened, and you put it at the end of the pipe, right? So this is like very high level stream kind of construct, right? So I think we can see that, yeah. Stream of events, B and C process all of them. B says, oh, that's interesting. And C says, I don't care. But he still like looked at it, right? He still looked at it. So I said a little bit more formally. So it looks formal now, right? So interestingly, so when we look at that though, notice that we've already got like a big benefit just from this thing, that A makes no assumptions around who will process that event. In fact, A does not talk to B. A no longer is dependent on B. B is not dependent on A either. In fact, it's like we've reversed the dependency through this event kind of object. It's like, oh, A is dependent on the event, and B is dependent on the event. They're no longer dependent on each other as services, right? Yes, exactly. And interestingly, also, we've removed time from this thing, because so one interesting thing, and you may not see this, but events persist within this pipe kind of forever. So it means like stuff doesn't get pulled out of the pipe. It's not a queue where I'm putting things on and people take them off. They just get written to them, and writing it is a permanent thing to that pipe. So that means into the future, so maybe a day later, a new service D might appear, and he might process those events from the beginning. So it's not like the something happened box there, element number 2, is processed by B and removed out of the stream. Not at all. He's there and he's seen it, and he's done stuff based on it, but that event still remains there for anyone else to see as well, if that makes sense. So it's permanent. So it means we've removed time. Our dependency on time is gone. Whereas in the earlier, in this kind of model, we were quite, like, time was quite important here. Like, B needed to be around when A said do something to him, right? If he wasn't there, like that command only was interesting while there were two parties around, the originator and the submitter and the receiver, right? That command is not not processable by someone at a later date. I suppose you could build a thing, you could build a queue or something to do that. That's fine, but it's like fundamentally, it's not really, right? A and B are connected in time as well here. Whereas once things are in the event stream, like, time actually is now, it's now more optional. It's not to say that it's like completely optional, because of course time is important, but it's like they're no longer coupled in time, if that makes sense. Okay, but like, what about state? So our person service wanting, like, wasn't he trying to fetch addresses from the address service? So like, how does that work? So like, so remembering that, I don't know if it maps into this diagram perfectly, but like, these guys are wanting to make changes to addresses, but they also want to be able to fetch addresses from that service. So like, how the hell does that work, right? And so there's a reminder of that like piece of code. It's like, remember that, right? So how is this going to work now? Person service used to have a list of addresses in him that he used to go and fetch from the address service. So it's like, okay, so how do we do this actually in the event, in our new model of thinking about events? Well, here's one way. Is the address service. So if you think about what can the address service do, he's probably got a couple of kind of like methods on him, right? He has the ability to create, like people can ask him to create stuff, update stuff, and delete stuff. Let's think about. So these are the mutation sides of what he does. Not so much the fetching side, but what changes can he make to state? It would be kind of be in that kind of category, like the CRUD type of category, right? So like ignoring the fact of how he gets those instructions, let's just say he does this. So when he gets an instruction to create, he just emits an event which says, hey, address number 1 was created. And same for update and delete. It's like address number 1 was updated. So here it was created, here it was updated, address 2 was created, and then address 2 was deleted. So we can certainly model the state changes in terms of events. And with him still keeping his kind of validation functionality that he used to do. So prior in our old model, he used to validate stuff before he made those. He can still do that. So assuming he gets those instructions, he can perform his validation. And instead of him writing to a state somewhere that he owns, he just emits an event that address has been created, and maybe he generated a number or something like an identity or something, right? So that makes sense. So he validates or cleans addresses, which we're very good at. I think in the product area we're very good at cleaning addresses. So here's how you should do it. No, I'm joking. Okay, so that means so that makes sense. Addresses state can be manipulated like that. So how do services now fetch that state, right? And it's like, okay, well, here's one way. It's actually quite simple. The person service who needed addresses, because he's processing that event stream, whenever he sees that an address is created, he would just internally, he would pick up that message and go, oh, look, a new address was created. Let me go and put that into my own state store of addresses. When that address gets updated, he picks that up and he does that. So he mutates the state change on which he had anyway, if you think about it. So like earlier, he kind of did have the list of addresses. So he still got that list of addresses, but now he's processing events to keep that list of addresses up to date, right? So does that kind of make sense? I think so. I think so. Yeah. So that's how the person service would go and fetch addresses from the address service by processing all the events of the state changes that the event service makes, and therefore have all the state already. So when you think about that, actually the person service never needs to go and ask the address service for state. He already has it. It's like it's there. It just exists. This is the idea. So earlier, I think there was this like pull versus push thing. So this is the idea of like state being pushed to consumers fetching state, if that makes sense. Okay, isn't it also interesting that the address service has managed to externalize its state entirely, actually? So in fact, we are back to that like stateless picture where the address service prior had this database that he used to keep up to date with all the services. He doesn't really need that anymore, because in fact he just writes those events down to the event store, and in fact that little database state thing has moved into the person service now. So I put a dotted line there because it's like, well, of course it doesn't really work like that. The person service is processing the events off of this event stream and maintaining it, but technically we've managed to get to that dotted line that with the projected idea of address services now projecting state into some other service. So another way, like you might hate this. This might just be, you might just say, oh, this is crazy. Like this Tom is fucking talking garbage. Like the stuff fundamentally is like wrong. It's totally fine. That's the whole point of this conversation is to go, yeah, let's like talk about it actually. And that's cool. I'm not telling you to do this. I'm saying here, like I'm showing you the controversy, right? But the way I start to think about these things is to go, actually we've separated, I think we've quite clearly separated two aspects of state here, of like state concern, right? Is we've said, hey, there was like something about the changing of state. So, and remember with changing of state, we said validation is important and there could be rules around those state changes, like that's important. So changing state is separated from the state itself. Does that make sense? So like, and the way I like to think about it is you go, actually, we do want to continue to centralize our state changing like function. You know, like the changes to state should be centralized to the thing that is responsible, right? So like the address service should be responsible for changes to state. I agree with that. I think that's right. However, the state that it holds doesn't necessarily have to be centralized. Like distribute that. So distribute the state itself. That kind of makes sense. So like I separate these two things and I go, yeah, centralize the functions that change state, but distribute the state itself. Like that's pretty interesting. Because when you do that, you get good benefits because I've got distributed state. That means I don't have to ask anyone else for state. I've already got it. But I've still got that concern of like, no, but I want to encapsulate and isolate changes to state. It's like, yeah, that's good too. That's also a good thing. Here we can, maybe we've got both actually. Maybe with this model, we end up with both. And I put a dotted line around this to say, within the context of that thing, so within the context of the address service, we can separate these two concerns, yeah? But hold on. So how many of you are going, wait a minute. Wait. There's nobody. No hands up. Everyone's happy with this? Are there any comments at this point? Is nobody brave enough maybe to ask? Or is it, does it all make sense? Doesn't make sense? Am I talking crazy? Okay, I'll carry on. Okay, so here is the madness, right? The person service now has like all the address data inside it. Like, is that what we want to do? Like we've just said, wait a minute. So like the person service, which is concerned about people and persons or whatever it does, has now got like all the address state inside it. And it's like, yeah, that's what we're saying. Yeah. That is literally what this is saying. It's saying, yeah, do that. Like, and if you missed that, it's like, no, I'll reiterate. That's what we're saying. We're saying, put all the addresses that the person service is interested in into the person service. Okay. That should make you feel uncomfortable. It certainly makes me feel uncomfortable. And the answer is like, yeah, that is a key issue. That is absolutely an issue. But it's an issue that can be solved within the like technology, the problem domain. It's like an essential piece of complexity actually. And so, and there are mechanisms. So like one of them is like materialized views. There's partitioning. There's all sorts of other like tricks to say, wait, this is like nutty. Like we don't want to do that. Maybe but we remember we kind of did want to do it. We just wanted to do it like temporarily or more permanently, but just a small amount of it or whatever it was, right? And so there are tricks to do that, and usually that now bleeds us into like the more practical world. Now we leave the theoretical world and we go, okay, practically this is a problem. Theoretically, it's not really a problem. Actually, theoretically, it's brilliant. We want all the addresses in everything that needs an address. Like it must be there. That's better. That's fast. It's more performant. It's always up to date. Like, yeah, that's a good thing. If that makes sense. But they mustn't be able to change it. They must just get the state, be able to look at it. They can't change it. If they want to change it, they've got to ask the address service to make the change. And when that happens, it'll like materialize and process into their state. Does that? I think we're happy there. So we're not going to dive into this key problem, but you should feel uncomfortable, which is it's a good feeling. So interestingly, I think this is more of an aside. I think I'm actually getting towards the end, which is cool. I'm going to be on time. There's another way of categorizing state this I think is actually really cool. It comes more from the functional reactive programming world. And they actually take state and they say, yeah, this problem is not as general as you think. There's actually different kinds of state, which are interesting. Some of them are events, and those are important, like an address changed or an address was deleted or whatever. Like those are important, but then and those they call events. But there's another kind of state which is that they call a behavior, and a behavior is more a mirror on that like query. It's like I just need this thing right now, so I'm busy processing an event. I'm busy with thing. Like someone's asked me to dispatch the order. So at this moment in time, like the address information becomes interesting and I need to go and look at it. And in the functional reactive world, they separate these two things into two concepts, one called behaviors and the other called events. So like you can think of them as different classes. You could say events are more important. Events are absolutely have to be processed. There's all sorts of interesting things like ordering is important, etc. Whereas behaviors are more like an analog for like a query. I just want to look something up quickly. This is like, I don't care about all the changes in state over time of this thing. I just want the latest one. I just care about the latest thing. That you could call a behavior. So in functional reactive world, they separate these two things, and that's quite cool because from a practical perspective, you may handle them quite differently. Behaviors are something where you're okay to throw away older versions of this thing maybe because you know you're only going to need the latest one, right? So like that's a behavior. I just need to keep it up to date or whatever. It's like my balance. I don't care what my balance was yesterday. I only ever care about it today. Because maybe I'm processing payments and I need to make sure people got money in their bank accounts or whatever. I don't care about yesterday's thing. But events are like, hey, make a payment. Like, okay, fuck, I mustn't mess that up, right? I need that, and I need to make sure that I process that thing after I process the thing just before it. Like there can be no messing around with the ordering of events. Whereas a behavior is like, let me just check he's got the right balance. Yes, he does. Cool. Carry on, right? So functional reactive separates these two things. And so we might see that in like the next thing. Anyway. So another thing that may make you feel uncomfortable is like, okay, but now that we have this picture with the person service maintaining all the state of the address service, and remember, this could just be in memory, right? He's just like, oh, I'll just process events and I'll just keep stuff like in this code here. Like, yeah, I just got it as like an object or whatever, like a list of addresses in my memory. So as I process them, I just keep them up, right? So if it is in memory or if it's in some kind of temporary storage thingy, so what happens when he dies? And it's like, yeah, that is a problem. His memory will be lost. But this again, we like now move into more of the practical. How is this? This is a key problem, absolutely. But like theoretically, it's really no real problem because if the person service boots up and he doesn't have any state, he should just go back to the earliest point in time in the event service, of which he does have state, which could be empty. It's like if you've got no state, then guess what? You've got to start at the beginning of time and start from there, and you will rebuild all of that state into memory. It could be that, so now we move more practically a little bit, but like you could imagine a technology might say to you, hey, you know what, you're keeping the state up to date. That's awesome. Maybe every now and then I'll give you the ability to like snapshot that thing, to write it off to a disk somewhere, or write it out to a database or wherever, right? Or put it on S3. And when you do die and you come back up, we can take that state that you had earlier created and we can restore it back into your memory somehow, right? You could imagine that a mechanism like that may exist. And that way, all you have to do is reprocess from things where you know, from the point of that snapshot, where that snapshot was taken, right? And then reprocess all the events, which could be that you had already processed them for sure. But that may be a quicker way to restore, right? Yes, that might take forever, but yes, but we could technically solve that with something like what I just described. Sorry. So so those are like maybe the immediate concerns you might have. A more interesting problem you may have is, but what happens when the schema service, like what happens if the structure of that state changes? So like, you know, today we kept addresses. It was line 1 to 4 and a postcode. And then into the future we went, oh, you know what, we forgot about the country thing. Like now we're going global. We need to add a new country field to our addresses. And it's like, oh, bugger, because now actually, like the state is not here. We can't just add that into the address service, like remembering that everyone else has actually got the state. Like we don't have it anymore. It's kind of committed into this event stream thingy. So it's like, yeah, that's a problem, right? and we know we can't go back and change old stuff, or like, or we shouldn't. It would just be dangerous. But so how do we solve this? And absolutely, like once again, this is one of the things we have to solve. So and the way we solve it is through versioning. It's actually quite simple. So when A emits stuff, this is the address service emitting stuff. He puts things, hey, addresses change, whatever, and we've got to make sure that those events are pretty strictly versioned. Each event in that stream needs to take with it like a version tag with it, right? That means immediately that B, while he's processing those things, can make a decision. He can say, oh, I'm picking up this new event. And the first thing it can do is it can look at that version and go, oh, bugger, like this thing has changed. And he can make the decision whether like he should process that thing or not, right? I mean, that's how you would manage this thing, right? So he's got a whole bunch of V1 type of stuff in his memory, and actually it's up to B to make the decision as to what to do at that point in time. Yeah. So one solution to that fundamental problem, and we'll definitely see this like in Kafka. Kafka does this tremendously well. They've got a service called the Schema Registry.
Yeah,
Schema Registry. Correct. Yeah. And you see this actually, I think, in other places. So like AWS Glue, something, the data is also kind of this. It's like a versioning of schema, right? It's allowing you to make changes to stuff, but keeping the schema of the old one, allowing changes to a new one, and potentially allowing configuration around querying it, whether it's forwards compatible or backwards compatible, potentially. I mean, you could imagine that as these things are designed, you could support that. So I'll just talk you through like the scenario quickly. So we've got A here, and he wants to emit this little green event, right? He wants to emit that thing. So before he emits it and before he writes it to the stream, he may query the catalog and say, hey, so here's the catalogs database, and that catalog in it knows about a yellow blockie, and the yellow is version 1, and the orange blockie is version 2. But A's got a new blockie, a green one. So he says, what version is this catalog? And the catalog says, didn't know about that version. No problem. And it inserts it into its little brain. It puts the green blockie, and it says, like, it's version 3. So the catalog tells service A, hey, this is version 3. Version A goes, service A goes, no problem. So he emits it, boom, into the event stream, and you can already see that the event stream had little boxes or little squares of various versions in it prior, right? So it writes it on as 3, just onto the end, no problem, boom, he emits it. So now we've got service B that's meant to be processing these things, right? And maybe he has processed 1 and 2, and that's fine. He knew about those, he was cool. So he has a little peek at the stream, and he goes, oh, it's a green blockie. He peeks it, and he then says, I don't know what to do. Like, I'm not aware of this one. I've never seen a version 3 before. So he will ask the catalog, hey, catalog, like, am I allowed to handle V3 stuff? And the catalog then is configured because, and you can see, sorry, it's configured because there was like a setting in it. You see that little compatible flag there? Previously, the yellow and the orange one had a little tick, meaning that the catalog would say to be, yeah, go for it. Like, try your best. Here you can see the cross has been set. And actually, this is a way of maybe managing compatibility of things. It's almost like a forwards compatible, backwards compatible flag. I mean, I'm just putting it here. Of course, it's a little bit more complicated than this. And the catalog just says, no, you can't. You don't know about this. Like, you will die. And it's because some human has set that up. The human has said, don't allow B to grab these green ones, because if he does, he's going to bugger stuff up, right? Or he'll die. And then he just chooses to go exit. Cool. There's nothing I can do. So I must just exit. Like, that's a good, I mean, that in this example, I would think is probably a good choice. Like, just exit, because it's very likely that from now on, we're only going to get green blockies put into our stream. Do you know what I mean? Like, A is unlikely going to put an older version of something after this V3. He's probably done a full upgrade. It's like, this is a new version of code that's deployed in A. So it's probably the best choice for B to just say, cool, I'm out of here. I'm done. I'm no longer useful for version 3 stuff, right? And if you think about this over time, this is a good way of doing it actually fits really well with like a DevOps kind of approach to software, because it's like I can kind of deploy A's which put new versions of stuff into the world, and services that would have not been happy with those new versions will kind of just tend to exit. So we'll see them exiting, and it's probably because there are new versions of B just about to appear. Do you know what I mean? Probably this deployment was like a new version of A and a new version of B arriving. Of course, they will arrive at different points in time into, like, if it was a Kubernetes or if it was onto an AWS or whatever. There's no atomic way of launching two processes at exactly the same point in time. So like A might deploy, starts running, and the old B is still sitting there going, oh, bugger. He sees some of this new A stuff and he just says, I'm out of here. Like, I'm not going to mess things up. I'm just going to exit. And a new B appears and goes, oh, no problem. I know where old B was. Old B was up to here. So I'm going to pick up this new one. I'm going to ask the catalog, hey, am I cool with V3? And the catalog is going to say, go for it, dude. You're good now. Do you know what I mean? So that's kind of, I mean, at a very high level, like what you expect to see in an event-driven world around versioning of schema, if that makes sense. So the idea here is like you never really go back in time and change stuff. You make changes into the future, but you allow the software components to be able to query the versions and make their own decision as to what to do with it. And with these mechanisms, you can create a pretty cool, like a fairly reliable way of deploying software, if that makes sense. Okay. Yes. Yes.
I had a question. So what about purging old versions off of the stream or out of the catalog? Because now if a new C arrives, he's going to have to understand how to read version 1, version 2, and version 3.
Yeah.
So would you ever go purge like version 1, for example? Or is it like
you could,
case by case?
but actually technically C, if he starts up with no state, like empty list, he needs to be able to go and read 1, 2, and 3. Like he needs 1 and 2 because that contains prior state. Do you know what I mean?
Yeah, sure. Okay, that makes sense.
Yeah, but it could, I mean, of course. So like you know, in a theoretical world, that's the answer. The answer theoretically is like C must always be able to process old stuff, unless he gets to the point where he's processed it and he's snapshotted it off somewhere, and that means when a new C comes along, he just like restores that snapshot and he never needs to go back to those earlier records. And if you know, like if you know for like an absolute fact that no one ever into the future will ever need those things, you can of course go and truncate the stream. You can just say like truncate earlier than this, you know, no problem, of course. But in the theoretical world, we've got infinite amount of disk space and infinite amount of thing, like you have no such problems, right? So those are more practical level problems. So yeah, absolutely. So something like Kafka has got a great way of doing compaction. So you can tell Kafka, like, you know what, like if there's 3, you can almost say to him like, hey, like these 3 blockies here, the little yellow ones, if they're all for the same key, we know for a fact that people are actually only interested in the last one. We know for a fact that these first 2 are just like are arbitrary because they're just going to be overwritten by the third one. Do you know what I mean? If you know that, you can tell Kafka, hey, go and compact this topic. And Kafka will run through that process of going, oh yeah, let me just throw away things that could be considered duplicates in this thing, because I know that people are only going to be interested in the last one. Do you know what I mean? So that's totally possible. So you can think of compaction as like a function you can apply to the stream that will kind of compress it by throwing away some of the information that you absolutely know is not useful. It's like MP3 compression, right? Throws away the sounds that you know that the human ear can't hear. Even though they are there and they are important, like, you know, practically nobody cares, right? So you can compact it out. So there are techniques around doing that for sure, of course. Yeah? Are you happy with that,
Yep.
Matt?
Yep, cool. Thanks, Tom.
So then there's like so maybe this speaks to scaling also. So it's like, okay, but now this thing's got to be like infinitely long, right? We don't have an infinite size disk. Actually, we do. It's called S3, right? Isn't it infinitely long? I don't know. So of course, so like technically, how does it actually scale? So I mean, definitely scaling is left to the implementation. So Kafka, Pulsar, Kinesis will scale differently. They all typically use something called like partitioning and keys. Key by is very common in partitioning. And I'll show you just like